Good day, students. Welcome to mathgotserved.com. Hopefully, you're having a wonderful day wherever you're at. In this presentation, we're going to be going over how to graph and analyze parent-trig functions. This standard is covered under pre-calculus and trigonometry. If you'd like to gain access to the playlist, the entire course, or other valuable learning resources, just take a look at the links in the description below. If this sounds like what you're looking for, don't forget to hit the like and subscribe buttons. Alright, the instructions for the example we're going to be looking at are as follows. We're to sketch the given graph on the specified domain. Then we'll describe the behavior, where it's increasing or decreasing. We'll find the extrema, relative and absolute, and then the concavity and specify the points of inflection. Okay, so let's say we have the function, uh, the parent-trig function y equals sine x, and we're to graph and analyze it on the interval negative pi over 2 all the way to 2 pi. Okay, so let's go ahead and start with the graphing part first. So we have this parent-trig function y equals sine x. You notice there are no numbers anywhere, just sine and then the x. If you have a parent-trig function, you can easily determine what the amplitude of your trig function is and what the period is. Okay, so this function can be written as y equals, the coefficient here is the invisible coefficient, which is 1 sine, and then the coefficient of x is 1 also, 1 sine 1x. Okay, so writing it in this format helps us to see what a and b are. Okay, so in this setup, we can see that this is your a value. Your a value is 1, and your b value is 1 also. So a and b helps us to figure out what the amplitude and periods are. So let's start with the amplitude. The amplitude of the parent-trig function, sine and cosine, you can just determine that by looking at the absolute value of a. So in this case is the absolute value of 1, and that's 1. So that means that you're going to go 1 unit up and down from the central position. Okay, 1 unit to the max and 1 unit to the min. The period, think about a complete cycle. Okay, this one can be determined by calculating 2 pi divided by the absolute value of b. So b is 1 here, so we're looking at 2 pi divided by 1, which is just 2 pi. So that helps us to see that 4 tick marks, which represents your quadrants, will give us a full period. Okay, so when we're setting it up, we're going to set it up like this. 4 ticks will give us 2 pi. 4 ticks will be your period. Okay, now let's go ahead and set up our graph. So there goes our y-axis, then the x-axis. Okay, so let's calibrate the x-axis first. Okay, so for the calibration of the x-axis, as indicated earlier, we're looking at the period. Alrighty, so we have 4 tick marks will give us a full cycle. So 1, 2, 3, 4. So let's say first tick mark, 1, 2, 3, 4. Okay, so this is a full period, which is 2 pi in this particular example. So 2 pi, half a period is pi, or 180 degrees. A quarter of a period is pi over 2. So this is 90 degrees, 180, 270, or 3 pi over 2, and then 360, or 2 pi. That's a full cycle. Okay, and then to the left here, we're going negative 90 degrees, or negative pi over 2. Alright, so now if you take a look at this interval right here, it can also be written using the inequality notation. It can be written as negative pi over 2 is less than or equal. Now, this bracket basically means that this endpoint is included. So we have the line here, okay, less than x, and then x is less than 2 pi. Parenthesis means that this endpoint is not included. How do you show this graphically? Well, the bracket on the graph is illustrated using a closed circle and the parentheses using an open circle. So this is exclusion, this is inclusion. So less than or equal to, closed circle, less than, open circle. We got to keep that in mind. Now we're going to go ahead and indicate what our amplitude is. So it's 1 unit up and down. So I'm just going to use 5 tick marks. 1, 2, 3, 4, 5. That takes us to the maximum. And that takes us to the minimum. Okay, so what's the size of these max and min? We calculated that here is 1. So 1 unit to the max and negative 1 unit down to the min. These are the upper and lower bounds of our graph. So let's go ahead and um, put our boundaries on there so that we don't cross them. Alrighty. So let me make this purple. So this is your maximum displacement from the central position. Let's put the upper bound there. And this right here is your minimum displacement from the central position. Okay? When we're graphing our points, we will try not to exceed these boundaries. Now that we have our max and min graph, let's take a look at the points. Let's graph the points now. So in order to graph the sine function, we need to have a general idea as to what the points, the configuration of the points are. Alrighty, so we need a guide. Let's specify what our guide is on the upper right corner here. So the guide for the sine and cosine functions. So for sine, think about the first letter of the word sine is S, right? So the sine function is basically like an S. So let me show you what I'm talking about here. Draw that again. So your sine function is like an S, so it goes like that. Bam, that's one complete cycle, okay? So 1 point here, 1, 2, 3, 4. Like that, and then it goes in the other direction, just like that. Okay, so this is what your sine function looks like. So don't forget, your sine looks like an S. Okay, and then the cosine, C, what does that one look like? The cosine function looks like a cup. Okay, so you have something like this. That is one complete period or cycle of the cosine function. You see how it looks like a cup? So you have a maximum, center, minimum, center, maximum. So that's one complete period to the right. To the left, following the same orientation, that cup to the left. So max, center, min, center. So these are the guides, okay? They help us to basically visualize how we're going to graph our points. In this particular example, we're graphing the sine function, so we'll follow this orientation here for the sine. All right, so sine, positive or negative doesn't matter, they always start at the center. So we graph a point at the center. So center, and then one tick mark takes you to the maximum, center max, and then the next tick mark takes you back to the center. All right, and the next tick mark to the minimum. So this is how periodic functions behave, right? They follow the same pattern over and over again. And then to complete the period, one tick mark takes you back to the center, but we have a parenthesis here. So this point is excluded from the graph. So we have to illustrate that using an open circle. All right, so that goes one period of the sine function to the right. Going to the left, we're just going to go a quarter of a period, or 90 degrees, or pi over 2. Alrighty, so the point is going to go down here. Bam. Now let's connect our dots. Now when we're connecting the dots, you want to pay close attention to the concavity of the graph. Okay? For the sine function, when you're above the x-axis, you are going to be concave down, and when you're below the x-axis, you're going to be concave up. Okay, so with that in mind, let's go ahead and draw the graph. So to connect these two, we have it's going to be concave down, or like a dome or umbrella, concave down. And then when you're underneath, it's going to be concave up, like a satellite dish. Let me draw it again. So it's going to be concave up, like that, and then concave up to the right endpoint. Right there, so concave up. So don't make it straight, you got to curve it, all right? So that goes one period to the right, and then to the left, is going to be beneath the x-axis. You're going to be concave. It's going to be concave up. Okay, so concave up like that. Bam. All right, so there goes our sine curve. Now we're done graphing. We're now going to go ahead and analyze the graph. Okay, so the first thing that we are going to determine is the behavior of the graph. Where is the graph increasing and where is the graph decreasing? Let's go ahead and specify that. So let's start with increasing first. So the graph is increasing wherever it's going up from left to right. Okay, so going from left to right. So let's go ahead and indicate that on our graph. So we can see that it's going up from left to right from, let me put the 0 here, from negative pi over 2 all the way to pi over 2. Alright, so let's go ahead and specify that. So it's going up, up, up. So that's what increasing is. You go from left to right. Okay, it's increasing all the way up to here. Do you see another interval where this graph is increasing? From 3 pi over 2 to 2 pi. So in that interval also is going up, 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 all the way up. Alright, so let's go ahead and specify our intervals where the function is increasing. So it's increasing from negative pi over 2 to pi over 2. We're using parentheses because at the extremes it's neither increasing nor decreasing. Alright, and then it's also increasing union 3 pi over 2 to 2 pi. Now, had it been that 2 pi were a closed circle, since it's an interior point, we would have put a bracket here. But since it's an open circle, we have to exclude it since it is not included in the domain. Alrighty, so there goes our behavior. Increasing. Now, how about decreasing? Decreasing is where the function is going down from left to right. Okay? So where is it going down from left to right? We can see that it's going down from left to right from pi over 2 all the way to 3 pi over 2. So it's going down, 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 down. Decreasing, decreasing, keeps decreasing all the way down to 3 pi over 2. Okay? So let's go ahead and specify that using our interval notation. So from pi over 2 all the way to 3 pi over 2, the graph is decreasing. Next thing we want to figure out is the extrema. Alright, so for the sine curve, the extrema are basically your peaks and valleys or endpoints that you're ascending to, descending from, descending to, or ascending from. Okay? Alright, so let's start with our minimum, local minimum. Or let's use the word relative min. So let's say relative min. Relative min are our low points, our valleys, or the points that you're ascending from. So this point right here is a relative min because you're ascending from this point. So this is an R min. This point right here, an interior point, this is a minimum because it's a valley. Okay? Alright, so let's write it down. We have a relative min of y equals negative 1. They both have the same minimum value of negative 1. And they occur at x equals negative pi over 2 and x equals what? 3 pi over 2. Bam. Alright, now how about our relative maximum? Our relative maximum are endpoints that you ascend to, descend from, or your peaks in your interior. Alrighty? So if you take a look at this point right here, this is a peak, so it qualifies as a relative maximum. Now you're ascending to this point. This point could have been a relative maximum, but since it's an open circle, it's not there. Okay, it has to be excluded. So we have only one relative maximum, and it happens at y equals 1. The value, sorry, is y equals 1, and it happens at pi over 2. Alright, so there goes your relative max. Alright, how about your absolute minimum as the lowest of the low? You can't go lower than that. On this graph, there are two relative minimas here, and they are at the value y equals negative 1. so that x equals negative pi over 2 and x equals 3 pi over 2. So something to keep in mind is that every absolute extrema is a relative extrema, but not all relative extremas are absolute. Okay? So all absolute minimums are relative minimums, but not all relative minimums are absolute. Okay? Is the lowest of the low that is the absolute. Alright, so for absolute maximum is the highest of the high in this entire domain that we graphed here. So let me put this here. This is also an A min, and as an A min 2. How about A max? This is the highest point, absolutely, on this graph. So this relative max also happens to be an absolute max. Okay, so we have an absolute maximum of y equals 1, and it happens at x equals pi over 2. Okay, so those are our extremas for this function. Now let's go ahead and talk about the concavity. All right. All right, so we're going to look at concave up first. So what does concave up look like on a graph? So think about concavity as the orientation of a U. Is the U facing up like a dish, or is the U facing down like an umbrella? Okay, so concave up, I'm going to say CU, is graphically is a U that's opening upwards like a dish. Okay, it could be a full U opening upwards, or it could be any portion of this entire U. As long as the opening is upwards, it's considered an upward concavity. So something like that. Okay, let me fix that a little bit. So you have a U facing up, or a portion of it. So this one's going up, concave up, just like a satellite dish, and this is also opening up, just like a dish. Okay, so that's what concave up is. So let's look at this graph. Can you see the intervals where the graph is concave up? It's concave up from negative pi over 2 to 0. So let's specify that. So it's concave up here, concave up, all the way to this point right here. And then it switches to the other concavity. Any other places? From pi to 2 pi is also concave up. So it's concave up, 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 concave up. So this entire domain, the graph is concave up. All right, so let's go ahead and specify that. So it's concave up from where? Let's see. It's concave up from negative pi over 2 to 0. And then where else? From pi all the way to 2 pi. How about downward opening concavity? What does concave down look like? Well, it's just the reverse of this, right? Is a U that is opening downwards like an umbrella or a dome, right? So if you have a full U facing down, or any part of it, right? So just a portion of it, as long as it's opening downwards, it's downward opening concavity. This is concave down, concave down. All right. Now, let's look at the graph. Do you see the intervals where the graph or the function is concave down? So it's concave down from 0 to pi, right? So it's concave down, down, got a dome, concave down, concave down, concave down, concave down, concave down, all the way to the center. And that's it. Okay, so let's go ahead and specify the downward opening concavity or downward facing concavity. So concave down occurs from where? 0 to pi. Last behavior we want analysis that we want to specify is the point of inflection, our poise. Okay, point of inflection. So what's our point of inflection? The point of inflection are the points where concavity changes. So let's go ahead and take a look at the graph for a second. Do you see any points where the concavity changes. Absolutely. Right here, this point right here is a point of inflection. Let's call it a poi. Okay? Why? Because at this point, the concavity changes from concave down to concave up. Do you see another poi on this graph? At 0, you have a point of inflection. Why is that? You have a point of inflection there because you're changing from concave up to concave down. Okay, so let's go ahead and specify what our points of inflection are in this graph. So it's points of inflection, there's two of them. So we have points of inflection at x equals 0 and x equals pi. Alright, so that's basically how you draw and analyze parent trig functions. So which of these properties of this graph is easiest for you to find and which is most difficult? Let us know in the comment section below which one is easiest for you and which is most difficult, and tell us why you feel that way about the choices that you selected. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your studies of graphs of trig functions, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about what we covered here, or if you want to make any requests for tutorials, just place it in the comment section below and we'll be more than glad to respond. Do not forget to subscribe to our channel. We upload videos to our page on a regular basis, so don't forget to subscribe to get updates. More support resources can be found at mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.